Hi, Tees. How's it going? Mr. Cortez here from UEI, and I wanted to make a video basically introducing switches, right? So the main focus of you in this program should be coming out of this program being really familiar with the different ways that we switch devices, how we switch lights, how we switch motors, how we switch fans, right? The whole point of an electrician is to install conductors, install raceways, and to then install controlling apparatuses, right? What that means is basically how to control these things, right? We don't obviously want the lights on always. We want to be able to turn it off. Same thing with garbage disposals. Same thing with small motors, motor garage door openers, right? So things like that, we have to learn how to understand switching, right? So once you understand switching, the other more complex aspects of electrical construction, such as um, motor control, PLC, things like troubleshooting, right, will be a lot easier to understand if you have a good understanding of switches. Okay, so that's what this video is going to be about. We're going to go over the different types of switches that we most commonly see out there, at least for you as an ET, and what you should focus in on the labs at UEI to be able to master. Okay, so let me share my screen and we'll go over a couple of these different switches and how to wire them. So right here, what you see on the screen are the three main switches that you want to get plenty of practice here at UEI. You want to have lots of labs with these, and you want to, again, really understand how you can control many different things with just these three basic types of switches. Right? So we have a single pole switch, we have a three-way, we have a four-way, right? There are, of course, many other different types of switches, but those three are the foundation of everything else. Okay, so understanding those is key and how electricity works and how we use switching to control, um, like I said earlier, equipment, motors, lights, heaters, anything you can think of that uses electricity. Okay, so first off is how can we tell what type of switch we have in our hands, right? That's going to be objective number one, particularly for you as an ET, right? You're going to be tasked with retrieving switches to getting material ready, organized material. So for you to understand what switch you have in your hand is crucial. Okay, so to know what a single pole switch is, and if you have a switch, a single pole switch in your hands, and any switch by that matter, is by counting the number of screws on the switch, right? So um, for a single pole switch, you'll have a switch that only has two brass screws, and I'm highlighting them right here. Two brass screws, right? So we are not counting the ground screw, right? Grounding, of course, is extremely important, and I'm not going to go into grounding in this video. And we'll make another video explaining grounding and how we ground. But right now, this video is focused purely on the hot and the neutral, the circuitry, right? But again, please make a note that grounding is absolutely essential. It's per code and it's for life safety. So if you're not grounding things properly, that's not up to code. You have to learn to ground everything properly. And like I said, I'll make another video explaining grounding in detail. But right now, the most complicated part is the circuitry. What do you do with your hots? What do you do with your neutrals? Okay, so to identify a single pole switch, as we were saying, it has two brass screws, right? So we won't count the ground green screw on all these, right? How to identify a three-way is that it has three screws, two brass, and one black. That's commonly referred to as the common screw. Okay. Has nothing to do with the neutral. Okay. That is just referred to as the common screw. Put a little C on there. And then two brass screws, right? Again, we still have the green screw, but we're not counting it, right? So if it's got three screws, it's a three-way. We got two screws, single pole. And if it's got four screws, it's a four-way. And that's what we see here. Four. You got two black and you got two brass screws. right? So that's number one, is first identifying what type of switch you got, right? Single pole, three-way, and four-way. So um, with that, now we're going to get into a little bit of how electricity works, okay? How electricity works and how we use um, power cords and how we conduct the labs here in UEI. So first off, we're just going to we're going to start with how electricity works. Okay, so electricity works in what's known as a closed loop. Okay, so most everybody's familiar with the term hot and the term neutral, right? And again, we're not focusing on ground. So with the hot, right, typically it's going to be a black wire. And in our labs, we use these power cords that you see on screen, right? And those power cords will always have a black, white, and a green. Right? The black is your hot wire. The white is your neutral. And we're going to go over what that is. So in a panel, for example, in a residential or a commercial panel, your hot would come from a breaker, right? Now we'll make some other videos explaining a little bit more of that in detail. But basically, when we use our power cord, we're simulating power being drawn from a breaker, from a panel. Okay, so you'll always have your hot and your neutral and your ground, of course, right? So the only two things that any load needs, and what I mean by load, LOAD, is that anything that uses electricity, just really to operate needs a hot and a neutral. It doesn't necessarily need the ground to operate. It's just not operating safely. Okay, so if you were to grab this power cord, plug it in, right? The black wire would be where the electricity would start. That's your hot wire, right? So if you were to connect that black wire to the brass terminal on a light base and then connect, if you were to plug this in and you just have the hot wire plugged into your light, electricity won't flow, right? Because it needs a closed loop, like I mentioned earlier. What that means is that we need the neutral to come back to source. What it means by source, come back where it came from, right? It started from this power cord on this black wire, then it goes to the light, then the electrons will go through the light, and with that neutral making contact to the neutral back on this power cord, electricity will flow. So we follow the electrons, they're starting here, right? They're going to go through the light, and with the neutral, they're going to connect, and you have a closed loop. So electricity will flow and the light will shine. Okay. If you have a cut anywhere along either the neutral, say if you just cut that wire, electricity would stop flowing. Right. Same thing with the hot wire. If you were to just cut that, there would be no physical way for these electrons to get to the load and with the neutral come back to source. Right. So if we were to just plug this cord in just how we have it wired here, it would turn on. Right. But the problem is that we won't be able to control it. There's no way to control it unless we unplug the power cord or go and kill the main power supply, which is inconvenient, right? So what we do to control is that we use switches, right? We use switches to do just that, is to interrupt the current flow and then to let it flow again, right? So we're going to go over how we use all these three different types of switches to achieve that control. Okay, so I'm going to start with the single pole switch. So I'm going to grab the single pole switch and let me paste it here. I'm going to make it a little bit smaller so it doesn't have so much trouble loading, right? You'll still be able to see the two screws. So with switches, what we do is that we intercept the electron flow from the hot wire and we insert the switch in there. So essentially what we're doing is that we're allowing current to flow through the switch or we're stopping the current flow in that switch. So if we grab the single pole switch, go right here, then we grab our hot wire, right? We call this our constant hot, because it's always energized, right? Until we again unplug it or kill the breaker. So we're going to go with that wire to one of the two terminals, doesn't matter which one. Then from the other terminal, you go to your load to your light, right? The brass terminal on this light fixture. Then your neutral does not go anywhere on the switch. It simply bypasses it and goes back to source. So when the switch is on, electricity flows through the switch and on the wire, turns the light on. When the switch gets turned off, it cuts that current flow and there's no more electricity. That light turns off, right? So that's all we're doing with a single pole switch. We're turning it on or we're turning it off, right? So now let's say that we wanted to have 2 points of control. So let's say that we have a really large room and we have two doors that are opposite of each other, right? We want to turn the lights on or off from either switch. So in that situation, we would not use two single pole switches because if we use two single pole switches, both of the switches have to be turned on. If one of the is turned off, the other switch isn't doing anything because it's just a linear um, uh, path for the current to flow. So you would not put two single pole switches. That's where we would use three ways, right? So three ways allow you to control from either switch on or off, regardless of the position of the other switch. Okay, so how we do that is that whenever you want 2 ports of control or more, you're going to use a three-way. You're going to use two three-ways with each other. Okay, so let me show you how that works. So we're going to take off the single pole switch and we're going to grab this three-way, paste it, and let me make this a little bit smaller so it fits. I have to cut off some of that wire right there. Copy this and paste. And right there. And what I'm going to do to simplify this and make it a little bit easier for you guys to understand and for the wiring to not be as confusing, I'm going to flip this so we have our constant right here. So just side note, remember that the position of the screws may not always be the same. Sometimes they're diagonal. What counts is the color of the screws, whether it be brass or whether it be black. Okay, so what we're going to do is that we're going to go with our constant hot to a first three-way. We're going to go to the black screw and only two there. Then we're going to grab what we call our traveler wires and connect brass with brass. And electricity does not know what color it's in, right? It's just like water. It has no intelligence or eyes, right? The color's for us to determine where we're at, if it's a hot, if it's neutral, if it's a traveler. So travelers, these wires that are connecting the two three-ways together are hot wires, but it would be too confusing to say connect the hot wires together, right? Because this is constant hot, this is hot, and the last wire is also a hot, but they have different functions. The constant hot is the wire that's always on, and that's always going to be on until we kill the power. That's your constant hot. These are called travelers. Travelers. Trying to fit it in there. Travelers. They're also hot, but they're called travelers. And then this last wire, right? We connect the two brass together. Then on the second three-way, that black screw is what we call our switch leg. Switch leg. So with these travelers, you don't necessarily have to connect them in the same position, right? What I mean is that you can connect this wire here to over here, and you can connect this one to that one. That doesn't matter, right? As long as you're not connecting a traveler screw to a common screw, right? And we're also not going and splicing off from these travelers to hit anywhere else. You don't want to do that. The only thing that's going to our load or our many loads is our switch leg from our second three-way. Right. So right here in this situation, this light would turn it on or off. And this switch would turn it on or off. And this switch would turn it on or off, no matter what the position of the other switch may be. If you want to control more than one light or one load, you would splice off from this switch leg wire. So right there. And let me select another let's say we have another light, another color light that we want to turn on at the same time. So that hot wire would go to the hot portion of this light, right? And as far as our neutrals are concerned, this neutral would tie on to the neutral from that other light. And right here, you would put a wire nut. You would splice them together. And right here would be another wire nut, splicing that switch leg to hit both this light and that light. And the neutrals are grouped together to be able to provide that return path back to source. So right here, this switch would turn both lights on or off, and this switch would turn both lights on or off. Okay. When it comes to a four-way, so let's say that we want to control from more than 2 points of control. Then that's where we can use four ways, right? We can use four ways and we can use them and put as many four ways in between as you want. So let's say that we want 10 points of control. Now, something like that would be a little unusual, right? Unless it's a really big house and the customer is really adamant about having a lot of points of control, but that's not something regular. But still, uh, you can do that with four ways. So with the four ways, what we do is that we use two three ways on the beginning and on the very end, and we'll put the four way in between the two three ways right here. So I'm just going to start off with just one, and then I'll do a second one. Right. So right here, what we're doing is that we're intercepting the traveler wires that communicate or co-communicate from one three-way to another. So what we're going to do is that with these travelers, we're going to go on only tops and bottoms. We won't go to the sides. So what I mean is this red goes here, this blue goes there, this goes right there, and this blue goes right there, right? So now it doesn't matter. These travelers coming from the first three-way can connect to the bottom screws, and then the top screws will then have to connect to the second three-way. That doesn't matter, right? As long as you're not coming in and going to the two screws on the side. So how I remember is that the toggle will either select the two bottom screws or the two top screws. Okay, so that's how from this wiring, you can then, and then the switch leg here would still go and connect, let's say, these two lights. So now these three switches can operate it independent of the position of the other switches, right? If you were to add another four-way, you would do the same thing in between either here or right there, and you would do the same thing. You would intercept the two travelers coming in from the first three-way, and then the two travelers would continue on to connect to this four-way. And again, you can add as many four-ways in between as you want, right? And that would be able to control both of these lights. And always remember that the neutrals never go on these switches. They're going to group together and go back to source. Okay, so it's a short introduction that I wanted to do for three ways, single poles and four ways, right? Again, switching is absolutely essential for you as an ET, whether it be residential, commercial, industrial. Switching is the basis of everything that we do. We control electricity, we control power, right? So we have to learn how to wire these devices and how we can use them in multiple ways. Right. So I'll be making more of these videos. I'll get into motors and I'll get into different types of setups that we have. But please let me know if you guys find this helpful. Again, my name is Mr. Cortez, and if you guys have any questions, please feel free to send me an email and any feedback you guys can give me, I would appreciate it. All right. So hopefully this was informative, and I'll see you guys on the next video. Thank you so much.